So we're going to look at how to divide number bases. So we start with the first example here. 134 in base 5 divided by 4 in base 5. So dealing with this, what most students do is they'll convert this to base 10, convert this to base 10, then they divide the answer they arrive at and they convert it to base 5. But that's a boring way of looking at it. So let's just look at a more matured way. You know, big boys do big things and big girls do big things. So let's look at the more matured way of doing it. So 134 in base 5, the divisor is 4 in base 5. So I'm writing 5 here as a digit, breaking my own rule simply because we're dividing, okay? And I don't want it to be too boring to be writing 5 all over the place. So what we need to do first is we get all the multiplication for base 5. 4 is the divisor, and the numbers in base 5, 0, 1, 2, 3, and 4. So 4 in base 5, if we multiply it by 0, is a 0. 4 in base 5, if multiplied by 1, is the same as 4 base 5. 4 times 2 in base 5. 4 times 2 is 8. 8 base 5 is 1 with a remainder of 3. And 4 in base 5 times 3. 4 times 3 is 12 in base 5 is 2 with a remainder of 2. And finally 4 times 4 in base 5. 4 by 4, that gives us 16. In base 5, that is 3 remainder 1. So you get 3 and a remainder of 1 in base 5. So we've gotten the numbers that we need. So 4 into 1 we cannot. 4 into 1, 3. That gives us 2 times. 2 times this, that gives us 1, 3. So we subtract. This minus this gives us 0, 0. We bring down the 4. 4 into itself here, that is 1 times. 1 multiplied by 4 is 4. So if we subtract, we get 0. Therefore, 134 in base 5 divided by 4 in base 5, our answer is 21 in base 5. Our answer here is base 5. So this is for the first example. Let's look at the second example. The second example we have is 213 base 4 divided by 3 in base 4. So applying the same I there, 2 and 3 in base 4 here, in base 4 here, and then 3 in base 4. So looking at the number bases in 4, 0, 1, 2, and 3. So 3 in base 4 times 0 is 0. 3 in base 4 times 1 is 3 base 4. 3 in base 4 times 2. 3 times 2 is 6. 6 in base 4 is 1 with a remainder of 2. So we get 1, 2 base 4. 3 by 3 is 9. And 9 in base 4. That gives us 2 with a remainder of 1. So 3 into 2 we cannot. 3 into 2, 1. So which number do you multiply by this that will give you 2? And that's 3. So it is 3 times. 3 multiplied by this, 2, 1, minus. So this and this gives 0. We bring this 3 down here. 3 into this. Which number do you multiply by? When you multiply this and this, what do you get? 3 here into this. Now, 3 in base 4 into 3 in base 4, that is 1 times. 1 times 3 is 3, so you subtract, you get 0. Therefore, 213 in base 4 divided by 3 in base 4, the answer is 31 base 4. Okay? And then we move to the third example. The third example is a bit challenging because we're having divisor to be 2 digits. And that's the reason you won't see questions like this in most of the textbooks. In most textbooks you look, you won't see questions like this. Okay, so you get 2115 in base 7 divided by 1, 2 in base 7. So here we use 2115 base 7 and 1, 2 base 7. So in base 7, 1, 2 in base 7 times 1 is the same as 1, 2. So you have to work this one out. 1, 2 times 2 in base 7. 1, 2 times, because the numbers in base 7 are 0, 1, 2, 3, 4, 5, 6. We're skipping 0 because we know that multiplied by 0 is 0. Okay? So 2 by 2 is 4. Write it here. 2 by this one is 2. So you get 2, 4 base 7. You get 2, 4 in base 7. 1, 2 base 7 times 3. If we multiply it by 3, let's see what we get. 3 by 2 is 6, right? 6. 3 by 1 is 3. So we get 3, 6 in base 7. 1, 2 base 7 times 4. See what we get? If we multiply this by 4, here, 4 by 2 is 8. 8 in base 7 is 1, remainder 1. The other one, 4 by 1 is 4 plus 1, 5. So we get 5, 1 base 7. 5, 1 base 7. 1, 2 base 7 times 5. If we multiply this by 5, see what we get? 5 times 2 is 10. 10 in base 7, 1 remainder 3. 5 by 1 is 5 plus 1, 6. So we get 6, 3 base 7. 12 in base 7 multiplied by 6, the last digit. 6 here. 6 by 2 is 12. 12 in base 7. If 1 remainder 5. 6 by 1 is 6 plus the 1. You have it to be 7. And 7 in base 7, 1 remainder 0. So we get 105 in base 7. 105 in base 7. So now we have 2, 1 here. But if you look at the figures, we have 2, 4. So we go for this. So 1, 2 into 2, 1 is 1 times. 1 times 1, 2 gives us 1, 2. And we subtract. Mind you, this is not 21 minus 12. You're dealing with bases. So this minus, you can borrow 1 we bring here becomes 7. 7 plus this one is 8. 8 minus 2 is 6. This one. So you now have 6 that remain. Okay. So what we do, we bring this 1 down. It becomes 6, 1. 12 into 6, 1 here. If you watch, you have 6, 3, but we have 5, 7. So we say 4. 4 multiplied by 1, 2. That will give us 5, 1. And this is not 51 minus 61. So this here gives us 0, and this here gives us 1. So what we do, we bring down this 5 down here. So bringing down the 5, 1, 2 in base 7 into 105. So this gives us exactly what? 6. So 6 multiplied by 1, 2 gives us 105. We subtract. Therefore, 2115 in base 7 divided by 1, 2 in base 7, our answer is 146 base 7. So this becomes the answer. So this is how you go about it. And now the fourth example, fourth and final example. The fourth example is 21021 in base 3 is divided by 1, 2 in base 3. So here, what we do, numbers in base 3, we know 0, 1, and 2. So very simple. So we get a division table here. 2, 2, 1, 0, 2, 1, base 3. And here we have 1, 2, base 3. So we get here 1, 2 multiplied by 0. 1, 2 in base 3 times 0 is 0. 1, 2 in base 3 times 1 is 1, 2. 1, 2 in base 3 times 2. Okay, 1, 2, base 3. 2 by 2 is 4 in base 3, 1 remainder 1. 2 by 1 is 2 plus the 1. 3 in base 3 is 0 carry 1. So we get 1, 2 in base 3 times 2. We get 1, 0, 1. All of these are in base 3. So these are the numbers that we have. So in this case, we say 1, 2 into 2 we cannot, into 2, 2. What we have here is 1, 2. So solution to this is 1. 1 times this is 1, 2. So we subtract this, now 22 minus 12. So here this minus this, 0. And here this gives us 1. So now what we do, we bring down this 1. Here. Bringing down the 1 makes it 1, 0, 1. 1, 2 into 1, 0, 1. That gives us 2 times. 2 by this is the same as 1, 0, 1. We subtract. And this here gives us 0, 0, 0. So we bring these 2 down. 1, 2 into 2 is 0. 0 times this is 0. And we subtract. We get 2. We bring this 1 down. Yeah. 1, 2 into 2, 1. So we say is 1 times. 1 multiplied by 1, 2 gives us 1, 2. Mind you, this is not 21 minus 12. We are dealing with base 3. So borrow 1, bring here. This becomes 4. 4 minus this here gives us 2. So this one becomes 1, 2, 0, 1 in base 3 with a remainder of 2. So therefore, 2, 2, 1, 0, 2, 1 base 3 divided by 1, 2 base 3. The answer is 1, 2, 0, 1 base 3 with a remainder of 2. So this is how you can go about dividing number bases. So you can take a screenshot, practice them in UNBAG. So lastly, we move over to special cases of number bases. Okay. So special cases of number bases, these are situations wherein you have unknowns. And in these unknowns, you have to work out for the unknowns. You solve what the unknowns represent, like the examples we're having here. So let's look at the first one. Example 1, we have 2, 3, 2 base x is equal to 92. This number is written without a base. That tells you it's in a base of 10. So here, what we do, we have to convert this to base 10. Say 2 multiplied by x, put it in a bracket, 3 multiplied by the base x, plus 2 multiplied by the base x. This gets power 0 because the unit number, power 1 and power 2, we equate it to 92. So we simplify further. X raised to the power 2, that is x squared, multiplied by 2, 2x squared, plus x to the power 1 is x, by 3, that gives us 3x, plus x to the power 0 is 1, by 2 is equal to 92. So looking at this, the highest power we have in here is 2. That tells us it is a quadratic equation. So we are going to bring this one over. So say 2x squared plus 3x. If this one comes out, it becomes negative 92. And negative 92 plus 2 gives us negative 90 is equal to this. So looking at this, factorizing this becomes a bit difficult because the sum is plus 3 and the product is negative 180. So you get big numbers and you have to waste time. So in that regard, what we do, we are going to look at the formula method. Formula method, if we compare this equation to ax squared plus bx plus c is equal to 0, which is the general form of all quadratic, it implies that a here is equal to 2, b is equal to 3, and c is equal to negative 90. So in that regard, using the formula, x is equal to minus b plus or minus the root of b squared minus 4ac over 2a. So if we substitute here, it implies x is equal to, wherever we see b, we substitute 3, negative 3, also minus the root of 3 squared minus 4 multiplied by A is 2, multiplied by C is negative 90, all over 2A means 2 multiplied by 2. So X will be equal to negative 3 plus or minus the root of 3 squared is 9, minus minus is plus, 4 by 2 is 8, 8 by 90 is 720, over 2 by 2 is 4. So this implies X will be equal to negative 3 plus or minus the root of 729 over 4. And 729 is a perfect square because 27 times 27 gives you 729. So X will be equal to negative 3 plus or minus 27 upon 4. So in this situation, we say either X is equal to minus 3 plus 27 upon 4, or X is equal to minus 3 minus 27 upon 4. So X will be equal to 24 upon 4, or X is equal to negative 30 upon 4. So in this case, X is equal to 24 divided by 4 is 6, or X is equal to, this gives us negative 7.5. Now you have 6 and negative 7.5. So your answer is this, because number bases cannot be negative. Therefore, X is equal to 6 as your answer. Okay, this is for the first example. Let's look at the second example. The second example is 132 base x is equal to 36 base 2x. So we say here 1 multiplied by x, because we're going to convert all of these to base 10, plus 3 multiplied by x plus 2 multiplied by x. Power 0, power 1, power 2. Write the equal to sign. 3 multiplied by 2x plus 6 multiplied by 2x, the base. Power 0, power 1. So this gives us x squared plus this gives us 3x plus this gives us 2 equated to. This here will give us 6x plus this will give us 6. So what we do, we can transpose this and we transpose this one here. So we'll have x squared plus 3x minus 6x plus 2 minus 6. So everything on that side now becomes 0. So we have x squared, work this out, we get negative 3x, negative 4 is equal to 0. So we have the sum to be negative 3, the product to be negative 4. So what two numbers, if we multiply, we get 3. If we multiply them, rather, we get 4, which is negative 4. And if we add them, we get 3. So the numbers will be 4 and 3. We get minus 4 plus 1. So we just say x minus 4 and x plus 1 is equal to 0. So it is either x minus 4 that is equal to 0, or x plus 1 is equal to 0. So x is equal to 4 or x is equal to minus 1. Therefore, our answer is, because number bases cannot be negative. So x is equal to 4. The reason why I did it like this, because the coefficient of a here is unity. So if the coefficient of a is unity, once you get the factors, you just put them in a bracket using the unknown that you are working with. So we go to example 3. Example 3, we have 134 in base n is equal to 54 in base 8. So similarly like we did for the previous examples, we're going to convert these to base 10, each of them. 1 multiplied by n plus 3 multiplied by n plus 4 multiplied by n. Power 0, power 1, power 2 is equal to 5 by 8 plus 4 by 8. Power 0, power 1. So this gives us n squared plus 3n plus 4 is equal to, this here will give us 40 plus that gives us 4. So we have n squared plus 3n plus 4 is equal to 44. So if we transpose this, n squared plus 3n, if this becomes negative 44 plus this, that's negative 40, 0. Two numbers, if we multiply, we get negative 40, and if we add, we get positive 3. Plus 8 minus 5 gives you plus 3. And the coefficient of A is unity, so we say n plus 8 and n minus 5 is equal to 0. So that is either n plus 8 is equal to 0 or n minus 5 is equal to 0. Therefore, n is equal to negative 8 or n is equal to 5. So our final answer therefore is 5. The fourth example. The fourth example here is 5, 6 base 3x plus 1 is equal to 2, 2, 1 base 2x. So like we did for the previous, we're also going to convert this to base 10. So it is 5 into 3x plus 1 plus 6 into 3x plus 1. Power 0, power 1. We equate it to 2 into 2x plus 2 into 2x, which is the base, plus 1 into 2x. Power 0, power 1, power 2. So this here gives us 5 by 3x gives us 15x plus 5 by 1 is 5. This, of course, gives us 1 by 6 is 6. 22. This gives us 4x squared. By this is 8x squared plus 2x to power 1 is 2x. By 2, that gives us 4x plus 2x to power 0 is 1. 1 times 1 is 1. So here, we have 5x and 5x, but let's say here, 15x plus, this gives us 11 is equal to 8x squared plus 4x plus 1. So we collect like terms. If we decide to move everything to the right, we get 8x squared plus 4x. If 15x comes over, it becomes negative 15 plus 4x minus 15x plus 1. If 11 comes over, it becomes negative 11. So everything here becomes 0. This can be written as 8x squared plus 4x minus 15 gives us minus 11x plus 1 minus 11 gives us negative 10 is equal to 0. So looking at this, we can use either the formula method or we use completing the square. But let's use completing the square method here. So for us to use the completing the square method, we need to make the coefficient of x squared unity. And making this unity means we have to divide all the terms by 8, because 8 is the coefficient of x squared. Divide here by 8, here by 8, and here by 8. This cancels, we are left with x squared minus 11 upon 8x. If we transpose this, we get 10 upon 8. This can be simplified further as x squared minus 11 over 8x is equal to 5 over 4. So now what we're going to do is the coefficient of x, we're going to multiply by half and we square it. The result we get, we add it to both sides of the equation. So half multiplied by negative 11 over 8 squared. So this will give us negative 11 over 16 squared. So this, we're going to add it to both sides of the equation. So here, x squared minus 11 over 8x plus, we then add this, negative 11 upon 16 squared is equal to, we also add this to the other side of the equation. So 5 over 4 plus into negative 11 upon 16 squared. So now looking at this one, this and this are having squares. So we're going to ignore this. We only consider this and this. So we have x negative 11 upon 16 whole square. So if you expand this, this is what you will arrive at. So it's a reverse process. So we have 5 over 4 plus negative 11 squared gives us positive 121. And 16 squared will give us 256. That's 16 squared is 256. So maintaining what we have on the left hand side, squared here is equal to, find the common denominator of 4 and 256. So we use 256. 4 into 256 is 64 times. And 64 multiplied by 5 gives us 320. Plus 256 into itself is 1. 1 multiplied by 121, we get 121. So here, we still write x minus 11 upon 16 squared is equal to, if we add these two, we'll get 441. That's 441 over 256. So now what we're going to do, we're going to take square root. Take square root. We take square root on both sides. So if we take square root here, we'll be left with x minus 11 upon 16, because the root, which is half, is going to cancel these two. So this now becomes plus or minus the root of 441 over 256. So this, we're going to transpose this. So x will be equal to, if we transpose this, this negative sign becomes positive. So we get 11 upon 16 plus or minus. This is a perfect square. 441 is 21. 21 times 21 gives you 441. So you get 21 over, and this is also a perfect square, that is 16. So now we have x is equal to 11 plus or minus 21 upon 16. So this is either x is equal to 11 plus 21 upon 16, or x is equal to 11 minus 21 upon 16. So this will give us x to be equal to, this plus this gives us 32 over 16, or x is equal to, this will give us negative 10 over 16. So the value of x here, 16 into 32 is 2 times, or x is equal to negative 5 over 8. But we know that number bases cannot be fractions and they cannot be negative. Our answer, therefore, is x is equal to 2. So the value of the unknown, which is solved for here, the x there is 2. Okay, so this is how you can go about working this. So we look at example 5. The number is written as 52 base x. 4 times the number is written as 301 base x. What is the value of x? So this number, 52 base x, if we multiply it by 4, this is the answer that we get. That is what the question is about. So meaning 4 times that number, 4 into 52 base x will give us 301 base x. So if you come across a question like this, what you do, you have to convert these to base 10 numbers. That is 4 into 5 multiplied by x plus 2 multiplied by x. Then also similarly, we look at this, 3 multiplied by x, which is a base, plus 0 multiplied by x, plus 1 multiplied by x. This x gets power 0, this gets power 1, and this gets power 2. This x here, power 0, this power 1. So we say 4 into x to the power 1 is the same as x. 5 multiplied by x gives us 5x plus x to the power 0 is 1. 2 multiplied by 1 is 2. We equate it to x to the power 2. That is x squared. 3 multiplied by x, 3x squared. Plus x to the power 1 is 1. By 0 is 0, of course, this gives us 0. X to the power 0 is 1. 1 times 1 is 1. So we can now clear this bracket. 4 multiplied by this gives us 20x plus 4 multiplied by 2 is 8. We equate it to 3x squared plus 1. So what we do, we can transpose over here. So we have 3x squared here. If 20x comes over, it becomes minus 20x. Plus 1 is already there. 8 goes, it becomes negative 8. So what remains on this side now is 0. So simplifying this further, 0 will be equal to 3x squared minus 20x plus 1 minus 8 gives us minus 7. So if 0 is equal to this, then also 3x squared minus 20 minus 7 is equal to 0. So looking at this now, we want to solve this. The sum is negative 20. The product is negative 21. So for us to get two numbers, we can multiply that will give us negative 21. And we add that gives us negative 20. It will be tricky. So we are going to look at completing the square method in this case. Like we did in the previous, we tried to make the coefficient of x squared unity by dividing by 3 throughout. So if we divide by 3, this becomes x squared minus 20 upon 3x minus 7 upon 3 is equal to 0. So we're going to transpose this. We have x squared minus 20 upon 3x is equal to 7 upon 3. So the coefficient of x is what we're going to multiply by half, and we square the result. So half multiplied by negative 20 upon 3, this one squared. So 1 multiplied by 20 is 20, 2 by 3 is 6, and don't lose sight of the negative sign. You square it. So this is what we are going to add to both the left and the right hand side of this equation. So we first of all add it to the left, x squared minus 20 upon 3x plus negative 20 upon 6 squared is equal to 7 upon 3 plus into negative 20 upon 6 squared. So here we say x minus 20 upon 6 all squared is equal to 7 upon 3 plus negative 20 is 400 over 6 squared. Negative 20 squared 400. 6 squared gives us 36. So in this situation, we write this x minus 20 upon 6 squared is equal to, find the common denominator, 36. 3 into 36, that's 12 times. Okay, and 12 multiplied by 7, that gives us 84. Plus 36 into itself is 1. 1 multiplied by 400 is 400. So this becomes x minus 20 upon 6 squared is equal to 484 over 36. So we can take square root on both sides. So taking square root of this, you'll be left with x minus 20 upon 6 is equal to the root of 484 over 36. So this gives us x minus 20 upon 6 is equal to plus or minus, the plus or minus here. 84 is a perfect square, which is 22 over 36 is a perfect square, which is 6. So in that regard, if we transpose this over, x will be equal to 20 upon 6 plus or minus 22 upon 6. So being that the denominators are common, so we can write this as x is equal to 20 plus or minus 22 upon 6. So either x is equal to 20 plus 22 upon 6 or x is equal to 20 minus 22 upon 6. So this plus this, x is equal to 42 upon 6 or x is equal to negative 2 upon 6. So here the value of x will give us 7, or the value of x, this is 6. The value of x will give us negative 1/3. Therefore, x is equal to 7. So the unknown we worked for is 7. Thank you very much for watching the video. Subscribe to this channel if you haven't subscribed. Like the video, comment, hit the notification bell to be notified each time we drop another video. See you in my next video.